Before we start the experiment, we need to understand the measurement principle. A signal generator is used to input a signal to a winding of the transformer, and then two channels of the oscilloscope are used to measure the signal between the two windings of the transformer. If the waveform phase of the two channels is consistent, it indicates that the winding terminal connected to the positive electrode of the oscilloscope probe is the same end. If the waveform presents a phase difference of 180, it is judged to be an unnamed end. The transformer we are going to measure today has a frequency range of 10 kHz to 100 MHz and a tie ratio of 1:1. After understanding the measurement principle, we began to wire. We use a signal frequency of 300 kHz, and then the amplitude is a sine wave signal of 15 volts. The yellow CH1 is the input signal and the green CH2 is the output signal. It can be seen that the oscilloscope waveform is now reversed. The phase difference is 180 degrees, and the positive electrode is connected to the anonymous end of the transformer. Now let's switch the positive-negative positions of the probe connected to the in end. You can see now that the two waveforms are completely coincident. This also verifies that the ratio of the number of ties between the two windings of the transformer is 1:1. The same phase indicates that the two probes now connected to the oscilloscope have the same positive terminal as each other.